Hello everyone, how are you doing? And hope you're doing well. This is Mohammed. I am in this video. I will try to explain what is the basic question that machine learning model trying to answer. And this video is targeted for TU Delft students, especially who are following the machine learning course in the computer science and engineering program. This is just a short video to give you a big, like to put you in the big picture of what we're actually doing in the machine learning course. What question are we actually trying to answer? What is the flow of this course? Based on my understanding, I hope it's well organized. And I just actually just draw here and design this simple map or flow where you can see where we start and what's the question we want to answer and where do we actually end up. So we have here, what does the machine learning model trying to answer? Well, at the very first beginning, we have here, for example, let's say we have here some raw data, and we would like to know, for example, if given an object, for example, this, we would like to know if this object should be classified in this as like class A or as class B based on a decision boundary that we will design later. So for example, if I'll have a point here or a point there or a point even here, how would I classify that? To which class should it belong to? So that's that question that we're actually trying to add and to answer. And classification is just the most simple thing that the most simple model that machine learning um, have some kind of. So we have different models, but classification is the most simple thing, and we'll build up upon this because, for example, for neural networks, use also classification um, in some way. And to answer this question, which is to answer this question is that like which thing belong to what, we need to know the posterior probability, and the posterior probability has this formula given Bayes rule or Bayes theorem, where the probability for y given x, this means that what is the probability that this object which has these features belong to this class, and what is the probability that this object which has these features belong to this class. And then once we know which probability is higher, then we can assign it to that class. And to answer this question, which is the post probability, we would like to know these. This is just Bayes rule or Bayes theorem. And for us to know or to answer this question, we have to know these. This is just the prior probability. This is the unconditional probability. And this is the conditional probability. And for us, the prior probability are almost like is almost known to us. The unconditional, we can compute it from the prior and the conditional. So the only thing that we care about and we would like to find is the conditional probability itself, which is this. So what is the probability that I have this feature given I'm from this class? Like for example, what is the probability that I am 180 centimeter tall, given that I am a man, for example? So that's the question that we would like to answer. And to answer this, the conditional probability, we would like to know what is the distribution behind this. Like for example, I would like to know to answer the question, what's the probability for me to be 180 given that I am a man? We would like to know what's the distribution for heights for men in general. For example, we have this here. This is for men, okay? This is the distribution of heights for men, for example. And the distribution says, let's suppose or assume here that it says that the probability for a man to have a height of 180 is blah blah blah, like some number here. So if I know that, I can just answer this question, and if I know this question, I can answer this question, and if I know this question, I can answer this question. And for me to answer this question, which is what is the conditional probability. I would like to know the distribution, but most likely I wouldn't be able to know the distribution. Why is that? Because for me to know the distribution, I would like to know all the data, and that is not possible in most cases. And in the case that it's possible, then that's not machine learning anymore. That's just matching between input and output. But for machine learning, I just know a part of the data, and I would like to somehow generalize what should I be doing with the unseen data. And for me to know the distribution without having all of the data points, I need somehow to estimate it. And to estimate the data, I can do that in multiple ways. And there are many ways in which you can estimate the data. And here in this picture, I just like brought this picture, which refers to the histogram density based estimation, which is just one way of estimating the distribution using the histogram and pins. And for us to estimate the data, we would like to take an approach, because there are many approaches in which you can estimate the data. One of them is the generative approach, one of them is the discriminative approach. For the generative approach is that most likely you can use it depends actually in how, when, what, in the context of what you're using it for. But for the generative models, like for example, an example of that is that if you don't have a lot of data points, you may use generative model, because once you use the generative model, you can generate more data, and based on all of these data, you can estimate your distribution. Or you can use the discriminative model, which you just take an estimation, and it has also some approaches. And if you can estimate the distribution using a generative approach or a discriminative approach, then you have an estimation for the distribution, and then you have the distribution, which is like almost the distribution. And then if you have the distribution, you have the conditional. And if you have the conditional, you have the posterior probability, and you have that, you can answer this question. Okay, so we reach this point, and after we have this distribution, we have classified somehow, we would like to test how good we are in classifying. And to do that, we do this in this step, which is just testing. And we see that, for example, we got some of them right, some of them wrong, then we have an error, and we just calculate this error and know, for example, that we may take in consideration, for example, that some errors, like the cost function, because for some errors that they cost us more than other errors, so we can take that into consideration. And for this, after we saw the errors, we can uh, somehow like evaluate and modify our parameters. Because what are the parameters here? For example, if we would like to assume that we have a normal distribution, then we just need some parameters, which is the mean and standard deviation. And if we know the mean and standard deviation, we can get this. But sometimes we don't get the results that we're hoping for, then we need to modify this. And if we modify this, the shape of the distribution changes a little bit, for example. And if it changes, the distribution changes that we assumed, for example. And if this changes, and this changes, and at the end this changes. And once this changes, we will test again, and we will see that we got a better results. And we do that many, many, many times until, like, yeah, as many times as we want, or we can, or we are hoping for, or we have money and time for. And then at the end, we see that we reach somehow the optimal case, which is like we have this is actually, this step is the training. Here happens the magic, like here where the actual magic happens. Here we're like training the model, and after that we get an optimal parameters, and these optimal parameters can represent our data the best, which can give this probability the best, which can get this result the best, which can draw our decision boundary the best, which is actually shown in this picture, we have drawn here a decision boundary, and this decision boundary classifies our data at the past. And now to answer the question that we first began with, which is, for example, if we have a data point here, how do we know which class is it from? Then what we actually just need to do is that we need to know the distribution, which we already know using one of these small approaches. And once we know, we answer this question and we answer this question, and then we have this decision boundary, and then we calculate what's the posterior probability here and what is the posterior probability here. We realize that the posterior probability here is higher, then we assign this point to this class. And yeah, that's it. I think that was just the answer for this question. I hope it's clear. I hope that I explained it well and what we're actually trying to do in this course, like in the course of machine learning. Well, I was a student and I suffered a bit understanding what was actually the big picture, and that's why I wanted to explain it for others. Thank you for watching, and yes, maybe we'll see you another time. Thank you.